All right, my 8th grade friends, you should see there at somewhere in your screen, let me get my marker off, sorry about all the shaking. Y equals mx plus b. Boy, that should sound familiar. Slope-intercept form, where m represents the slope of the line, rise over run. Rise, how far up or down, run, how far left or right, plus b, where b is the y-intercept, the point at which the line crosses the y-axis. Whenever we solve a system of linear equations, remember what we're doing. These are two linear equations. They represent a line. And in this situation, when we solve a system of linear equations, remember what we're doing. Okay, this is a review concept today. We're going to be building on this over the next few days. But for the next couple days, it's going to be pretty much review of things that we've done before. So remember what this is. These are linear equations, and our job is to figure out when we solve the system of linear equations, what we're doing is finding the intersection point. At what ordered pair do these 2 points intersect? Now, whenever we solve a system of linear equations, our first job, remember, is to make sure that the equations are written in this slope-intercept form fashion. Y equals mx plus b, where m is the slope and b is the y-intercept. And so these two are already written in slope-intercept form. So then remember what I do, I make them equal. So in this case, we're going to go negative x plus 3, and that's going to equal x plus 1. All right, so what I'm going to do is I'm going to take this negative x and I'm going to bring it over here by adding x to both sides. Okay, and so that's going to give me 2x. And then I'm going to subtract 1 from both sides, because remember I need a 0 on each side. And so I'm going to subtract 1 there. That's going to give me, 3 minus 1 is not 0. 3 minus 1 is 2. My mistake, 8th grade. So now I am left with 2x equals 2. Well, if 2x equals 2, I'm just going to divide by 2. 2 divided by 2, x equals 1. But you can't stop there. The directions do not ask us just to solve for x. The directions tell us to find the intersection point. An intersection point, remember, has an x and a y. It is written as an ordered pair. So once you know x, you have to plug it back into one of these equations to figure out what y is. Well, let's say x equals 1. If I want to plug x in for 1 here, it would be that y equals 1 plus 1, because x equals 1. Well, then y would equal 2. Well, let's check it with the other equation just to make sure. Once again, x is 1, so we have negative 1. Y equals negative 1 plus 3. Well, sure enough, negative 1 plus 3 is also 2. So very clearly, y is 2. My solution is 1, 2. That is the intersection point of those lines. So I come over here to example number 2. They will not always already be written in slope-intercept form for you. All right? Slope-intercept form, remembers this y equals mx plus b, where we need y isolated. So I look at this first one, x plus 2y equals 1. To get y by itself, I'm going to have to take x and move it over there. That's going to leave me with 2y equals, and since the x is going from one side to another, and here it's positive, I know over here it's going to be negative, then my plus 1 is going to stay a plus 1. All right, so I'm looking here, I'm like, well, 2y equals negative x plus 1. It's still not in slope-intercept form, though, because I need to have y by itself. Well, how do I get y by itself? I divide by 2. But if I'm going to divide this by 2, everything else has to be divided by 2. Y equals, so I'm going to take negative x and divide it by 2. Well, I'm not going to put negative x over 2. Remember, when I divide something by 2, it is the same as multiplying it by 1 over 2, the rule of reciprocals. Okay? Show you that again. When I divide something by 2 over 1, it's the same as multiplying it by 1 over 2. That's just a basic rule we learned back in division of fractions back in 5th grade. So instead of negative x over 2, this is going to become negative 1/2 x. And then that's going to become plus 1 over 2. All right, now for this one, y equals negative 2x, sorry, negative 2x plus y equals negative 4. If I want to isolate the y, I'm going to bring this negative 2x over to this side. When I bring the negative 2x over to this side, it's going to become positive because it's like I'm adding 2x to both sides to make it 0, and then I'm adding 2x. So this one's going to become y equals 2x minus 4. Okay, so y equals negative 1/2 x plus 1/2, y equals 2x minus 4. Well, now I have to go back to making them equal. I'm going to get myself a little more room here. Let's say, okay, I'm going to say that negative 1/2 x plus 1/2 is equal to 2x minus 4. All right, let me clear a little space here. Getting a little crowded. All right, but we were able to work the problem to this point. So let's think about what I want to do. Well, I'm going to bring this 1/2 x over here. And so I'm going to add 1/2 x to both sides, add 1/2 x. That's going to give me 2.5 x. That's going to give me 0. All right. So then I need to have a 0 on this side. So with my negative 4, I'm going to add 4 to both sides. That's going to give me 0. I'm going to add 4 to 1/2. That's going to give me 4.5. All right. So now I'm left with 2.5 x equals 4.5. All right. So I want to think, well, how is this going to work? Let me just turn everything into fractions. I prefer to work with fractions. 2 times 2 is 4, plus 1 is 5. 5 over 2x equals 2 times 4 is 8, plus 1 is 9. 9 over 2. All right, so remember now what I have to do. This is going to become 9 over 2 divided by 5 over 2. And remember, when I divide fractions, all I do is turn them into a multiplication problem. So if it's 9 over 2 being divided by 5 over 2, when I divide something by 5 over 2, it's the same as multiplying it by 2 over 5. I don't want to forget that. I can cancel out my 2's, make them 1's by cross-checking. 9 times 1 is 9. 1 times 5 is 5. I'm going to get 9 over 5. Depending on what you punch into your calculator, you could also get 1 and 4 over 5 by turning it into a mixed number. If your calculator is spitting out decimals, you could also very well end up with 1.8. All right, so x equals 1.8. All right, now let us remember, okay, and I'm going to clear ourselves some more space. I didn't really plan this very well room-wise, 8th grade. I'm sorry, that's poor planning on Mr. Swack's part. That normally doesn't happen. Okay, but we have x equals 9 over 5, could be 1 and 4/5, could be 1.8. Any 3 of those options will work. Those are all just 3 different ways of writing the exact same number. So we want to remember our original fractions. Okay, we want to remember our original fractions, which were x plus 2y equals 1 and negative 2x plus y equals negative 4. All right, so let's think, what do I want to do? Here I've got some whole numbers. I'm thinking mathematically, might just be easiest to use the decimal. So I'm going to plug in x for 1.8, okay? And I'm going to say, well, 1.8 plus 2y equals 1. Okay, then I'm going to have to subtract 1.8 from both sides because I want to isolate 2y. So I'm going to go y minus 1.8, which is going to give me negative 0.8. That tells me now that 2y equals negative 0.8. If I punch into my calculator 0.8 divided by 2, I'm going to find that y equals negative 0.4, or y equals 0.4, which means my ordered pair is going to be 1.8 negative 0.4, which is the same answer that my answer key has. So that's good for that example. So far, so good. All right. Number 3 looks a little different. 4x plus y equals 17, y equals 9. Remember, when we get a line that just says y equals 9, that just means it's a line that's parallel to the x-axis. Y is always 9. We're never leaving that plane where y is 9. There's no slope. It's just parallel with the x-axis, okay? To give you an idea, there's our y-axis. There's our x-axis. Let's just say that 9 is right there on our x-axis. A line that says y is 9 just simply runs right through there, and it's parallel with the x-axis. This concept really is not connected with this, though, but allows us to think of the line. In this situation, let's just make it easy, folks. They tell us that y equals 9. So we already know that it's going to be something and 9. The intersection point y has to be 9. It tells us that right there. So let's just make it easy. Let's just go and plug 9 into the equation. 4x plus 9 equals 17. I'm taking the 9 and I'm plugging it in for y. Well, now all I have to do is solve for x. Okay, that's very basic. Subtract 9 from both sides. Okay, that leaves me with 4x equals 8. Well, if 4x equals 8, 8 divided by 4 is 2. My ordered pair is 2, 9. Last one. This one looks like a lot of fun. All right, I'm going to clear some space up here ahead of time because I think we might need it. In fact, what I'm going to do is I'm going to rewrite these up here. 2x minus 3y equals negative 1. 5x plus 2y equals 26. All right, so we're going to start again. Here we go. First of all, it's got to be in slope-intercept form. All right, so what I'm going to do, okay, first thing I'm going to do is bring my 2x over. So we're going to work with this one here, and then we're going to be left with negative 3y equals, if I bring my 2x over to this side, it's going to be negative 2x minus 1. Okay? Now to get y by itself, I'm going to divide everything by negative 3. So y equals negative 2 divided by negative 3 is a positive 2 over 3. The negative and the negative just make it the positive. So that just becomes 2/3 x. When I take a negative 1 and I divide it by a negative 3, that becomes a positive 1 over 3. All right, so we come to this one. Once again, if I'm going to isolate 2y, I'm going to bring this 5x over to here. That's going to leave me with 2y equals negative 5x, because the 5x is going to become negative, bringing it over to this side, plus 26. To get y by itself, I've got to divide everything by 2. So y equals a negative 5 divided by 2x. 26 divided by 2 is going to be 13, a positive 13. And I'm left with this. So I've got y equals 2/3 x plus 3. Y equals negative 5 over 2x plus 13. Well, I have to make them equal. So 2/3 x plus 1 over 3 equals negative 5 over 2x plus 13. All right. Now this looks like a handy-dandy problem. All right. So I'm thinking, well, okay, let's bring my 5 over 2 and bring it over here by doing 2/3 plus 5 over 2 plus 5 over 2x brings me 0. So I've got to think, well, in your calculators, you should be able to figure that out. So most of you, a lot of you have a calculator just like this. If you need to, you might just need to do some scratch work, going back, finding common denominators and so forth. But most of you should be able to say, well, 2 over 3 plus 5 over 2 equals 3 and 1 over 6. Okay, so I'm going to end up with 3 and 1 over 6. Okay, 3 and 1 over 6x. Now, if you need to remember common denominator is going to be 6. Okay, so if I turn that into a 6, 3 times 2 is 6, and 2 times 2 is 4. If I turn this into a 6, 2 times 3 is 6, 5 times 3 is 15. Well, 4 plus 15 is 19 over 6. 6 can go into 19 3 times. If I take 6 into 19 3 times, there's 1 left over. My denominator is 6. So, the other option here now, since there's a 0 over here, now there needs to be a 0 over here. So I'm taking 13 minus 1 over 3, which is going to equal 12 and 2/3. So 3 and 1/6 x equals 12 and 2/3, which essentially then that's going to leave me with 12 and 2/3 divided by 3 and 1 over 6. Or 3 times 12 is 36, plus 2 is 38. So that's going to be 38 over 3 being divided by 19 over 6, because I already figured that out. So I can come over here, 38 over 3 divided by 19 over 6. Well, remember when I divide by 19 over 6, it's the same as 38 over 3 times 6 over 19. And this is where all those lessons back in 5th and 6th grade, 8th graders, pay off. Okay? If you don't have the calculator working, if you're struggling, remember these valuable lessons that we learned back in 5th and 6th grade. This is not difficult scratch work. And smart people like you, sometimes it's probably faster to do it on paper. But we ought to very quickly realize we can cross-check a 3 and a 6. 3 divided by 3 is 1. 6 divided by 3 is 2. If we stop and think, we can actually cross-check a 19 and a 38. They're both divisible by 19. 19 times 2 is 38. So 19 divided by 19 is 1. 38 divided by 19 is 2. 2 times 2 is 4. 1 times 1 is 1. 4 over 1, 4. X equals 4. But it's not good enough to know what x equals. It is not good enough to know what x equals. Okay? The only thing that's good enough is to know what x and y equals. So I'm going to bring my x equals 4, okay? And I'm going to bring my x equals 4 into one of these equations, okay? I'm going to plug in x equals 4 right here. Negative 2 times 4 is negative 8. Negative 8 minus 1 is negative 9. So that tells me that negative 3y has to equal negative 9. That's a very simple equation to solve. If negative 3y equals negative 9, to solve for y, I've got to do negative 9 divided by negative 3. Well, negative 9 divided by negative 3, very clearly, is going to equal a positive 3, which means my ordered pair, x equals 4, y equals 3, is 4, 3. Have a good day, 8th grade. We'll talk to you later.